for another episode of the Southwest Climate Podcast. As always, the indomitable Mike Crimmins. Mike?
Hey, Zach.
How you feeling?
This is the social distancing edition.
That's right. Yeah. We are at opposite ends of the table because...
Right. Because you didn't shower today.
Hey, you shouldn't necessarily make light of this. It seems like if trends continue, we might have to do this on Zoom in a month.
We could, and then I wouldn't have to shower then. We could just do this from home, actually. That's a good idea.
How you been?
I'm doing good. Yeah, I'm excited about the continuation of the rain here in southern Arizona, but we've got a fairly complex story to talk about across the West here. It has not been wet everywhere, and it's been kind of a weird winter. But they're all weird, I guess, right?
They're all different.
They're all different.
What's been weird about this for you?
Did that sound kind of derogatory?
No. Like I think weird is good, I think.
Okay. Yeah, I didn't mean to.
It's interesting. Weird is interesting.
I think so too. Yeah, I think that they're all a little bit different. So
what has stood out so far?
Well, I think the pattern of precipitation has certainly favored southern Arizona, and I guess we're going to get into the 30-day recap here. But just sort of the thumbnail sketch across the West has been, at least in the last 30 days since our podcast, has been the kind of a break point across the Southwest. Southern Arizona, wetter than average. Northern Arizona, drier than average. New Mexico, doing much better than much of the West. And then we'll have to sort of talk about the broader water situation. But California has been in pretty dire straits this winter again.
Yeah, I think when you look at the extremes, California in the last 3 months, maybe even a little bit longer than that, certainly sticks out. I believe that they've, in the historical record, which goes back 120 so years, the last month and the last 3 months were the driest. Pretty remarkable considering not too long ago, 3-4 years ago, I mean, that was a pretty epically dry period as well.
Well, I mean, just if you think in like the last 5, we've had epic snow conditions, atmospheric rivers to nothing.
Yeah, whiplash, climate whiplash.
Whiplash back and forth. I'm looking at some of the climate perspectives here from one of the regional climate centers here. San Francisco, for the last 30 days, has recorded 0.08 of an inch. That's the third driest period for the last 30 days. So that would have been like mid-February through mid-March on record. And we can go back down to Tucson, and Tucson has had 0.57 inches, and that's on the 48th percentile. So it's right around median. So quite a gradient from California to the Southwest as far as precipitation over the last, since November all the way through this last month.
Quite a bit of whiplash over the last number of years, but also quite a bit of whiplash within, the last 5 or 6 months. So if you go all the way back to October, so just recapping here how the winters unfold, because quite frankly, we're pretty close to the end of the winter here, at least in the Southwest. Maybe not so much up in the high country of Colorado and Utah, but we're nearing the end of the winter. I mean, the poppies are out.
Yeah, absolutely. Yeah, just in the last couple of weeks, we've really started to see the temperature rise, and we're almost at the equinox, so we're almost getting to half a day of sun, and so you can really feel the sun angle coming up. So the temps have gone up. Interacting with all that soil moisture, we've had quite a bloom of wildflowers across much of Arizona too. So
going back October, let's just walk through this a little bit. Dry across the Southwest, sort of the hinge line was Northern California, Northern Nevada, and Utah. And it got a sort of nearish average above that, but dry below that. Fast forward a month to November. November was one of the wetter months that we've experienced in this year, at least, and it top 10 percentile.
Yeah, with some kind of localized record wettest in northwest Arizona, parts of Utah, and then parts of southeast Arizona.
And it flipped, and that was the sort of the regional epicenter of dry conditions within the Pacific Northwest.
Right.
Okay, so then another month forward, November and December were wet in the Southwest.
Yep.
November and December were dry in the Pacific Northwest.
Right. And so even California started to pick up snowpack. And so California, Intermountain West, and Arizona at least looked pretty good. November into December, we had snowpack conditions that were above average, at least in Arizona. And you'd think even California had a period there where they had raced out ahead with some of the early season snowpack. New Mexico was a bit dry in December. And then once we moved into January,
this is where the dry conditions started to grip and take hold in California.
This is really kind of a broader kind of pattern change and has led into the weather conditions we're even seeing in the Southwest today.
So was this a ridging pattern that started basically in mid-January?
Yep. So it's been interesting this winter. If you start to look at the blogs and the discussions around ongoing analysis of this winter, and then now we're starting to do the postmortems, as you're saying, because we're kind of at the end of the season. One of the big defining features of Northern Hemisphere winter this year was a very strong positive Arctic oscillation and no breakdown in the stratospheric polar vortex, and a jet stream that was pretty tight up around the polar regions, right? So that's kind of that reinforcement of keeping the cold air at the poles. A retracted jet, a jet that's strong, the mid-latitude jet is being kind of at northern latitudes. One of the expressions of that was this strong ridge in the East Pacific. And so what that has done is it's steered a lot of the storms in the Pacific Northwest and has induced this kind of inland trough in the western U.S. And so on the other side of that ridge,
but sort of coastal ridge then?
Yeah, this coastal ridge, which has then, so if you think of those storms are getting funneled up over across the Pacific Northwest, and on that front side of the ridge, you get this trough that's induced, and these low pressure systems will wander down the west coast or a little bit inland, and then they'll bottom out across the southwest. And what has happened is that there's been a lot of moisture in the East Pacific. And so we can even talk a little bit about the El Nino situation. We've had warmer than average conditions across the Eastern Pacific, but they haven't been enough to trigger an actual, it's not a weak El Nino event, and we don't even really see.
But that's almost like a little bit of an arbitrary.
It's totally arbitrary, right?
We have a threshold that we use in the temperatures that distinguishes it between an El Nino or a neutral, and the difference in a few tenths of a degree could
a binary change
could make it an El Nino versus
change.
Neutral, but practically speaking, it's not all that different.
Yeah, and I was reading the ENSO blog from climate.gov today, and they had a really nice presentation of what it goes through the classification of an El Nino event. And so it's not just the SSTs, even though that's the quantification of it. In the forecaster's mind, they're going to look for other patterns. But the point being that there really haven't been any large atmospheric shifts related to El Nino, but what there has been is warmer than average water in the East Pacific, which has also led to above average humidity and atmospheric moisture in the East Pacific. So as these low pressure systems would drop down in the western U.S., Arizona was in the right spot to pick up moisture from them. And so we've had a number of events in the last 3 or 4 months, and especially in the last 30 days, that have been subtropical moisture getting funneled up from the East Pacific as these low pressure systems bottom out in the Southwest. So what that leads to is it leads to southern Arizona and New Mexico being in that subtropical plume of moisture. Northern Arizona doesn't typically see the precip. And so that also leaves California out of play too. Like that is not the storm trajectory that you'd need to have those things barrel in and clobber the Sierra Nevada.
And that's actually what's playing out right now.
Yep.
And, by the time this pod drops, but it does look like this closed low is sort of move across the region and drop some of that subtropical moisture.
It's interesting because this pattern is not unusual, but we've had plenty of winters, and this will also happen into the spring in a lot of years too. You'll see these storm systems bottom out, but they won't have any moisture, and so they'll just be wind. Right? They'll come through and you'll have a slight temperature change and then you'll be back to warming up. But just having that moisture available, these storms have been able to tap into it and pretty efficiently and regularly give us these warm, wet events. This current event, and it's going to play out even into the pattern of next week, is a little further offshore. And so it actually brought Southern California into the mix this time too, and has been classified as an atmospheric river.
So there could be some relief for California.
Well, Southern California, but Northern California is completely out of play for this particular event. Again, the trajectory of this storm, the position of the low, the speed of the low has been able to thread the needle across Baja and bring up pretty juicy low-level moisture to record levels into Arizona with this event.
I mean, we lump California as one giant state, but I think we should say that the sort of more severe dry conditions have been in the northern areas.
It's been northern. It's been where the snowpack should be accumulating. So it's been
poor Sierras.
The Sierra.
I did want to go back to one thing that you said, though, because you brought up the Arctic oscillation. And normally we think of that in terms of temperature here in the Southwest, but you were actually sort of relating it to the ridge position, which obviously has implications for for rainfall. Are people thinking about the AO more recently in terms of a precip signal?
You don't see any correlation. Well, you and I have done this before. Yeah. We've had years with extreme negative oscillations and extreme positive oscillations and tried to make sense of it for the Southwest, and it's a mess. And there's not really any correlation. The eastern U.S., though, I think you can ascribe this winter's temperatures to a positive Arctic oscillation and trend with climate change. Right. It's like those two things together, and most of it is positive AO.
Right. The positive AO bottles up
the dreaded polar vortex. I'm doing air quotes right now. You can't see that.
I like them.
You didn't have the tropospheric polar vortex wander around much and make too many incursions.
But wouldn't that also influence the waviness of the jet and the position of the jet?
Yeah.
And so wouldn't that then also influence or increase the chances of, these closed lows or cutoff lows wafting down?
Yeah, but I think that again, I'm a bit out of my lane here, even though it's probably I should.
You have a very wide lane.
You can have positive AO situations, and given where other standing waves originate in the atmosphere, I mean, this could have played out differently. I think that you can have positive AO situations where the West goes under a ridge, right, or the whole continental U.S. goes under a ridge. I think this is kind of a unique situation. I don't know what other upstream forcing has caused this particular pattern, but what we do see in the pressure pattern is strong, persistent ridge of high pressure over the East Pacific, which at least through the end of January and much of February has led to this pretty persistent pattern. And again, we saw it, the outlooks, 6 to 10 day outlooks and 8 to 14 day outlooks by Climate Prediction Center had this weird pattern where California was dry and Arizona was above average. You've got to do this weird jet stream pattern to try to weave out a pattern like that.
Finish my train of thought as I was stepping through the months. So I just want to finish that because you did sort of describe it quite well, January and February. And both January and February brought warmer conditions to most of California, particularly the northern parts of California. And, in January, it was sort of southern half of Arizona was right around its normal precipitation. And then February actually brought enhanced wet conditions to southern Arizona, which you basically described the pattern for that. What about temperature?
Temperatures, just going back over the last 30 days, they've largely followed precipitation. So places that have been drier have been warmer. And places that have been wetter have been cooler. And so there's an interesting pattern across Arizona. So southern Arizona, if you go to southwest Arizona, it's been quite wet, like in areas like Yuma, which is unusual, right? And it's also, from an agricultural perspective, you do not want it to continuously rain through the winter season because it hampers productivity, especially with the vegetables and the leafy greens. And it also makes things muddy. So it's quite problematic. But it also has been cooler than average because of this recurrent low-level moisture and this sort of stream of clouds coming up from the East Pacific. Higher elevations in northern Arizona was like slightly above average because of just being on the little drier side of these systems coming through.
Okay, and so when we look at where we are in terms of the cities at this point, and there's still, a month-ish to go, although we're on the decelerating precipitation limb of the winter, if you will. So most of the rainfall has already happened in the Southwest, but there's still chances going forward. And here in Tucson, we're basically right at average. We're likely going to finish this year above average. It remains to be seen how much, but that's the situation in Arizona. So not an extreme winter by any stretch. Likely not going to be one in terms of rainfall, but a good one nonetheless. Phoenix, and it's close to average at about 4 to 4.25 inches.
And this would be October 1st through present.
That's right. We are factoring in October, although nothing happened in October, but really it started in late November. So I'm looking over the October
kind of the water
through,
year to present.
So so close to average in Phoenix, and Flagstaff. Flagstaff is actually, going back a few days, 3-ish inches below average. So Flag might come in a little bit behind.
It's interesting, too, because Flagstaff had a record dry monsoon season and is now headed towards a quite substantial deficit in the wintertime as well. Northern Arizona has a pretty protracted period now where they've been beat up from monsoon into winter season now.
If the Flag area did not get any rain from now going forward until the monsoon period, it'd be about, again, doing math on the fly here, about 80% of average.
It's not the worst ever.
Put that on top of a historically dry monsoon, and it really puts pressure on the upcoming monsoon.
It does, yeah. And the snow in Flagstaff proper has been about half of what is average for the whole season. So precip has been down. The actual overall, it's been, I think, warm. It's a lot of these storms as of late too have been high snow levels. Mm-hmm. So the precip that they've gotten has been not in probably the typical seasonal snow way. And again, for Flagstaff proper, I don't know how much that's an issue, but I do think it'll have impacts for some of the reservoirs, the lower elevation reservoirs in that part of the region, like Lake Mary. The higher elevations, though, are still hanging on decently. But again, March 1st is kind of peak snowpack for the Southwest. So we're on the downward slide for a lot of this as well.
So I think we should transition then and talk a little bit about this, the snow situation around the West.
I want to make one last point here. I want to highlight how far southeast Arizona has done precip-wise. I'm just going to pull up some rain log reports here. Given the storm track that we've been talking about here, if you go from Sierra Vista to Bisbee to over to like Safford, parts of southeast Arizona have had 3 and 4 inches of rain just in the last 30 days, which is quite substantial. Wilcox is almost at
right now it's
8.7,
almost 9 inches of rain, and their average is a little under 6.
Yeah,
so almost 150% of average.
9 inches of rain since October 1st, and all of that has come since mid-November. Over almost 4.5 inches in November proper. But then real decent, consistent rains.
Well, that's the thing. It's been consistent. There's, in the beginning of the season, there was a few larger storms, but basically beginning in December, there's been a steady flux of kind of small precipitation events. So,
that kind of consistency can make all the difference. Even if the totals aren't high, but you just, those consistent pulses of moisture really can do a lot for soil moisture. So I think, parts of southern Arizona are in really good shape. They got mediocre monsoon precipitation, and then getting ramped up with that November precip, throwing all that soil moisture into there, and then doing this periodic, I think has been really beneficial for southeast Arizona.
So has the number of low pressure systems that move through the area, has that been, I know you haven't looked at this data, but maybe use your memory here. Mm-hmm. Has anything stuck out to you about the number or the frequency of these events?
No. There have been some cool papers. It was one out of University of Utah that looked at kind of storm track frequencies and low pressure. The Southwest has got this huge bullseye on it. I think the fact that, so in a normal winter, and then as we transition to spring, we'll see a lot of these low pressures. The fact that they've been able to capitalize on a subtropical tap of moisture has been, that to me is what's stood out. And if you look at some of the data,
so is that just, are they able to do that because they're digging further south, or they're stronger and therefore they're advecting from a further area, or what? Why is that the case?
Well, and I'm looking at some of the reanalysis data here for. I'm looking at precipitable water anomalies in the East Pacific from February to present, and they're substantially above average just off of the Costa Baja. I think the access to the moisture, these are substantial anomalies. I don't have a sense of like that. Clearly, that wouldn't be all the time. It wouldn't be an anomaly then at that case. And if we look at relative humidity, specific humidity at kind of mid-levels, it's above average just south of here. So my guess is that moisture, and this is, I was trying to make that link. I'm totally baseless other than this is just observational. Above average East Pacific sea surface temperatures, they strongly visually correlate with where this above average humidity is in the East Pacific. So maybe that's like a connective tissue here about there's just been more East Pacific moisture at this latitude. And so with that storm track, that seems to be what these storms are picking up on. And
so
again,
background state of the moisture has just been higher for some reason.
It seems like it, yeah.
Can't necessarily attribute that, although
right.
I have high confidence in your eyeball regressions.
My eyeball regressions are world famous. And and if you look at the anomaly plots for the geopotential heights, so they'd be just looking at that kind of the average weather map in the middle level of the atmosphere. The only anomalies are in the ridge pattern in the East Pacific. There's not a low pressure anomaly over the Southwest, which would mean that it's transitory, right? Is that stuff is moving through quickly. So it doesn't really give you a sense of that frequency if it's being above average or not. To me, it really only stands out as this access to moisture to the south.
Okay, before I move on, now can I move on to snowpack?
Yeah, let's do it.
Not unsurprisingly, the snowpack condition obviously would follow the precipitation. And so the real bummer, as was mentioned earlier, is in the Sierra Nevadas, and many of the stations, SNOTEL stations, they're reporting below 25% of average, which is obviously has huge implications for the water supply there, for the people that tap into the snows. But, when you move, so I guess I should say that the other sort of bleak snowpack situation right now is in Arizona. Now, we don't have a lot of snow reporting stations up there, but Flagstaff looks to be the only region that has above average snowpack.
Yeah.
Headwaters of the Salt and the Verde are also showing less than 50% of average. And when you zoom in, Mike, on some of these, you can see that the rainfall hasn't been that much below average, but the snow, the water content in the snowpack is much below, and part of that I think is these warm storms story and the warmer temperatures.
I think it's killed the snowpack it's eaten it from the bottom up. And so the snowpack is really hanging out at the highest elevations. I was playing around with our SnowView tool. Some colleagues here at University of Arizona built this really nice interface that uses gridded modeled snow water equivalent data. Just looking at the lower Colorado region, all elevations, snowpack, what you'd expect is the median snow water equivalent starts to climb in December and peaks in February and then starts to fall. Well, what actually happened was we ended up having a big push and peak in snow water equivalent that was way above median in November. So it was that wet November again, which was, some of those storms were quite cold and put down quite a bit of snow, and especially at the higher elevations. And then it bottomed out in December and then climbed way back up above median in right around New Year's. And then it's just been on this slow decline and has crossed over to being below median at February 1st. And so all of February, it's been below median. It's not crashed or cratered. It's now kind of following the normal path of decline in snow water equivalent in Arizona right now, but it's below median.
But let me just go across some of the numbers. So basin-wide averages, Little Colorado is coming in at about 68% of the long-term average. Salt, 59%, Verde 70%, Upper Gila 84%. So those are pretty consistently dry conditions.
It's not like it didn't rain, or not like it didn't precipitate, right?
This is snowpack. Yeah.
This is where we're looking at a map of what basin-wide snow water equivalent. It's got that brown color, but these basins aren't necessarily dry.
No, I think
it's a little bit misleading, right? We're in this weird kind of
I think this
transition.
This is the story that you were just telling about these warmer storms tapping into the subtropical moisture, which brings with it not only moisture but also warmer temperatures. It's going to fall, that precip is going to fall more as rain than snow. So you can have above average rainfall and below average snowpack, depending on what your temperature conditions are like.
Right. And I think at this transition time, when snowpack is on the decline anyways, if snow water equivalent is below median, I'm not sure how much. I mean, I guess I'm saying this a lot. How much does that matter? Under
a median year, we would basically be at peak snow water equivalent.
Yeah.
Right now we're probably 10-15% of that. So it's going to melt out maybe the snowpack will be gone, and at this SNOTEL station will be gone maybe a full month
earlier than
normal.
Than median, yeah.
So that does matter for such things as extending the fire risk season, increasing evaporation, reducing stream flows. So I don't know. Is that a convincing?
Yeah. Again, it's these I would like to know what the background distribution is. Like I'm looking at this plot.
Well, this is median though.
It is median, but I bet it's a noisy distribution to get to that. Like how often does this? It's 7,900 feet in March. I would expect that happens quite frequently.
Yeah,
but it's also with the climate has clearly changed towards warmer, so maybe the expectation for that occurring is much higher now. Maybe that was in the 60s, which was very cold and wet. That would have been unusual to have it melt out this early.
Well, let's look at last year.
I'm just going to...
Because last year was a pretty snowy winter, if I'm remembering correctly.
Yeah, you're totally right.
Zach
so on March...
Mike 0.
Okay, March 11th, according to this would be the SNOTEL site. March 11th, 2020, snow water equivalent at Promontory is 1.9 inches. Okay, on March 11th, 2019, snow water equivalent was 12.4. It was 10 times the amount now. And it peaked again. And March 14th, it went up to 14.7. So, okay, I take it back.
Well, I don't know.
It's weird right now. It's weird. Yeah, it's melted out early.
1 year might not undermine your point, which is that it could be noisy.
Two's better than one.
Well,
could fit a line through it.
Is this year uncharacteristic, unusual? Probably not.
See, I think that's the challenge of interpreting Arizona low elevation SNOTEL sites. If we go up to the two highest peak ones, they don't have this kind of variability.
Well, so now I'm looking at Snowslide Canyon, which is Mount Humphreys, right around Mount Humphreys, 9,700 feet.
Yeah, that station's more like a Rockies. That looks pretty good.
And when you say pretty good, I mean it's 106% of its long-term average right now. So it's basically average.
So what about Baldy? So I think that part of the Mogollon is also at average to above average.
Well, I mean, this is the challenge. I mean, snow is highly variable in space,
Yeah.
I mean, we're going to get into this issue of like we're making these broad statements about snowpack conditions within a whole basin based off of.
Isn't it interesting? And we don't have that many SNOTEL sites. So March 4th, Baldy's snow water equivalent was at median. On March 11th, it was 60% of median. Like something happened in a week where it lost 3 inches of snow water equivalent.
What about, was there rain at that time?
At 9,100 feet? Yeah, maybe. This is why I don't use snow data.
It's hard. Again, we're just trying to get the big picture.
So what's the point of all this?
Right. So I was making a big picture point here.
I'm sorry. I kept going into the weeds.
And you helped me.
Kept trying to dig snow caves.
You threw me off that. I don't even remember what my train of thought was. Okay, so I was going over the conditions in different basins in Arizona, and as you go further north, the conditions get a little better. Parts of the upper Colorado River Basin are slightly below average, like the Gunnison and the upper Colorado are both around 90% of average, and then further north of that, the Yampa and the Colorado are both slightly above average. The picture across the West is one, again, just to summarize this, the bullseye for low snowpack Sierras. Right now, southern Arizona, you made the point that maybe it doesn't matter all that much, that we have seen a lot of rainfall, so it's not like it's been dry. But as you move further north, upper Colorado River and the Rockies, it's generally been about average. So I think that does have implications for streamflow. So let's talk a little bit about streamflow conditions, Mike, because at this time of year, everybody sort of tunes their eye to what the forecasts are for Colorado River. So let's get to that. I just said that it's a mixed bag, some below, some above average in terms of snowpack for the upper Colorado River. Turns out, however, that the forecast for inflow into Lake Powell is a lot below average. So what they're expecting is somewhere in the vicinity of, their best estimate is about 73% of average. So one of the questions is, okay, you've got a decently good or at least average snowpack situation. And yet the streamflow forecasts are calling for much below average. 73% is much below in my book. How can we reconcile that?
This is the forecast issued by the NRCS, right?
That's right.
The River Forecast Center model is going to ingest their estimates of snowpack, which I think is largely consistent with what we've been describing across the region. Also, the modeled soil moisture for present still shows some deficits as far as the amount of water to reaching saturation in parts of the upper basin. I think that's an input to the model. This would be, there's snowpack overlying presumably frozen soil. So as you melt, does that water turn into runoff, right, or does it turn into recharging soil moisture? I believe that's part of the model. And so there's some pretty large deficits across parts of the upper basin and actually the parts of the lower basin as well. And then this other component too is the percent of normal fall precipitation, which was, I believe, through November 15th, which was prior to the wet spell that came on later in the month, is also quite a bit below average as well. And so it seems like those two moving parts, I think, are giving the forecast models pause.
There might actually be a third one too, which is what comes next.
If they're using the seasonal outlooks, the time scale of the seasonal outlook versus some of the short-term products have been at opposite, like their signal has been pointing in opposite directions.
Yeah.
So I would think that would lead to enormous prediction uncertainty in some of the streamflow forecasts where the antecedent conditions are actually the primary driver.
Right. Well, I guess we can say this, though, with these forecasts, that we're late enough in the winter where the cone of uncertainty is a lot less than it was before.
Oh, yeah. I'm sorry. That was what you were trying to explain to me before, is that as you get closer to peak snowpack, you've locked in more of what's possible.
Yeah.
Totally. Absolutely right.
Yeah.
So where does that leave us then with...
In terms of how much more is to come?
So kind of a March 1st, the upper basin still has the chance to actually get April and May precipitation, which I don't think that's really incorporated.
Right. So if you look at it in terms of their probabilistic forecast.
Right. Okay.
So
got it.
Okay. So let me see if I can unpack this, because these are complicated graphs where they show you the percent of likelihood for different
Is this going to translate into podcast?
What it's telling us is that there's like around a 25% chance that it would be average or above. So there's a 75% chance that inflow into Lake Powell will be less than average. So the best guess is 73% of average. There's a small chance that it will be 100% or above. Presumably, this kind of information gives the decision maker a lot more flexibility, but it can be quite challenging to sort through.
I think it's interesting to try to reconcile the conditions we're seeing across Southwest, the Intermountain West, with the streamflow forecast. And it'll be really interesting to revisit it next month.
Right. Let me just run around though to New Mexico, because the other big river is the Rio Grande, and it's a similar picture. Although its best guesses for streamflow there are around 50-55%. So, and that is in part because the San Juan Mountains, which is where its headwaters are below average, whereas the Colorado River taps in part into the San Juan Mountains, but also into the more northern Rockies, which have seen above average snowfall. So point here, I think, is, snowpack kind of around average, but stream flows are below average. That's the big take home.
There's too many moving parts here. Like, I think we're dancing with this idea of, has it been a warm, wet winter or a dry, normal temperature winter? It seems to be temps and snow levels is what I'm struggling with.
I think it's been a normal precip winter but also when the precip has happened we're thinking about this as
you're right,
a monolithic picture, but the timing matters here.
Yeah, I think how it's translated into snow has not been super ideal. Yeah, right. And in the latest tick up in precip has been warm, wet storms.
Well, also look at a lot of this, the precipitation came in the early part of the winter, which, for these sort of mid-elevation sites could have already melted out,
And I think it largely has.
Yeah.
I think we've seen. But the highest elevation stations are still hanging in there.
All right. So when I was prepping for this and thinking about Streamflow, a couple big picture questions that I find interesting came to mind, right? One of them is, and go back to 2014. I had to look it up because 2014 is a long time ago, but we did this series, which you can still find on the Klimas website, where we called it 1075. And it was really this semi-deep dive into the Colorado River and what would happen when the Colorado River crested that threshold of 1075, which is the feet above sea level for Lake Mead, which means at that point, when it goes below it, sort of drought or shortage sharing goes into effect. So the policy measures kick in to create forced conservation, and that sort of ripples through different sectors and whatnot. So we did a sort of deep dive asking the question, what happens when we cross this threshold? Because at that point, it seemed pretty imminent.
Mm-hmm. Yeah.
Okay. So that was 2014. And every single year since then, we've kind of always been hovering around going into shortage declaration.
Mm-hmm.
And we're kind of still there.
Mm-hmm.
And so one of the questions for me is, and I don't know if you have an answer, and I'm not putting you on the spot here, but why haven't we gone why haven't we crossed that threshold? And, I did a cursory look at just the rainfall and the precipitation, and it's not because it's been copious amounts of rainfall over these intervening 7 years.
Yeah.
We've had periods of good winters and dry winters. So it's not like we've got a windfall and it filled up the reservoir. So to me, it's a question that we should explore a little bit further.
Yeah, and I think teeing up the idea for another podcast is definitely the way to go. I mean, like you and I have puzzled over the hydroclimate for almost a decade now, I think, with this podcast. And there have been those moments of Miracle Maze and March Madness. I think there were names for all of the late season precip rallies, but I think you're right. I don't think they're enough to totally explain away what's been going on.
So the newest projections, 24-month study by the Bureau of Reclamation, they look at this and they try to forecast in a probabilistic way when reservoir levels in Lake Mead will dip below that 1075. And they've got a number of different scenarios as you kind of have to do. You have to play with narratives here. In a more extreme version of this, where they just look at the last 20 years of data and use that as representative of the hydrology, there's a 15% chance of Lake Mead dipping below 1075 in 2022. That increases to 45% in 2023 and 54% in 2024. So we don't get to above a coin flip for another 4 years.
Yeah.
And then when you do a less extreme maybe isn't the right word, but when you use the full records hydrology, which incorporates years that, early part of the record where we didn't have the warming that we currently have, by 2026, there's only a 42% chance. So again, to me, it's like this narrative of we're in impending water shortage. It's obviously a real narrative, but I want to sort of understand like why. To me, I would have thought we would have already crossed it.
Yeah.
And there must be some really good reasons that we haven't, that are probably in part related to the climate, but probably in part related to a whole bunch of other complicated nuances.
Totally. I think all those other moving parts are clearly part of this whole story here that I don't know enough about. But yeah, I think doing that 1075 podcast follow-up, I think it's definitely timely.
So the other big question, I don't know if you have thoughts on this, and I don't know if we have time to talk about it, but the other question is for the Colorado River is what's the future hold in terms of climate? How is climate going to be impacting future stream flows? And there was what I think is a really good paper that was just published in Science that's got a lot of press. Some of the listeners might have heard that or seen news releases of it that asks the question, well, what's the what's the warming part of streamflow? What's the warming signal for changes in Colorado River streamflow? What's the title you're looking at it?
Colorado River flow dwindles as warming-driven loss of reflective snow energizes evaporation. It's a good title.
It is a good title.
Yeah.
It's a statement.
It is a statement, yeah. This is what's happening.
Facts are that over the instrumental record, last 100 and so years, Colorado River streamflow has declined by about 20%. And the question is, what's been contributing to that?
Right.
What's the climate part of that?
Well, it's all climate. The streamflow, the unregulated streamflow would be hydroclimate. It's the precip versus temperature, right?
That's right. That's what I meant to say. Yeah. Deconvolving the precip.
Yes.
Because one of the important parts of this is when we look forward, there's much more consensus around what temperature will do. Modeling consensus, like it's just an easier process to predict going into the future than precipitation.
Yeah, it's got baked in forecasting skill because of trend and temperature due to climate change.
Right. So understanding what the fingerprint of the temperature is an important thing.
Yeah, it gives you something to stand on as far as doing sort of shorter, kind of medium range planning.
Okay, so
years, decades.
So I guess the upshot here is that they were able, through a modeling approach, and their model looks, when they reproduce it and compare it to observations, it's a pretty tight fit. They obviously have to make some assumptions and
right.
They do some things that they talk about, but they come up with more or less a 9.3% reduction in stream flow per increase of 1 degree Celsius.
That's right. Yeah.
So that's the temperature. That's the stream flow sensitivity to temperature.
What's really interesting about this paper is that it's part of an ongoing discussion in the literature, including some colleagues here at U of A we work with, where doing this attribution exercise has been done largely empirically, just doing some regression modeling, looking at temperature and precipitation, where they came in here with a more sophisticated approach, especially on the evapotranspiration side. And so instead of using temperature as the component to energize evaporation, they argue that more sophisticated evapotranspiration schemes that really get at the process of what causes evapotranspiration, which is predominantly net radiation, that once you start to really get at that component, which is also going to be related to albedo and surface albedo and changes in surface albedo with snowpack shrinking, you get a more probably realistic feedback that's going to happen with changes in temperature and changes in ET.
Well, you're looking at the driver, you're looking at the process and not just the outcome.
Yeah, so temperature-based metrics are, temperature becomes a proxy for net radiation at the surface, rather than thinking about net radiation as its own variable, and then using that in a sophisticated evapotranspiration scheme and then hydrologic modeling scheme.
So right, so this is the key, I think, to this paper. This was what was really insightful to me. It's the change in snowpack, the change in temporal distribution of the snowpack that then drives increased evapotranspiration.
Yeah,
that then drives declines in the actual amount of precip that runs off into the rivers.
Exactly. So temperature is a proxy for a causal chain that's quite sophisticated. And so they added links to that chain and then broke them down. And then interestingly, they found estimates that weren't that different than the empirical based, but were a little bit better and a little bit tighter, I think, in the range.
Well, to me, it's always more insightful when you get at the process.
Yeah, absolutely. The discussion that had been started, took those kind of first fruits of the analysis, which you're kind of arguing we were offline, is that was a good way to start the discussion. But this then brings it to the next level, start to break down the pieces and the parts. And it also identifies some of the uncertainty that we really do have to nail down to really understand how this is going to change in the future.
The other nugget in here is that to come up with better estimates, you had to look at the monthly patterns of snowpack changes and not lump one winter into a single value because timing matters. And actually, I was thinking about this in terms of the struggle that you and I have had really in talking about the climate over such a broad region, is that it is temporally and spatially quite heterogeneous. And
I mean, just even trying to make sense of the current conditions today across the basin it's kind of a mess.
Yeah, you have to decompose these things both in time and in space.
Yeah, and you've seen, like, shout out to Connie Woodhouse, our colleague here. She's really started to break some of those pieces and parts down on the seasonality in their contribution to some of the Streamflow records, and then even brings them back into the paleo record at the same time.
Yeah, pretty cool paper. Millie and Dunne, Colorado River flows dwindles as warming-driven loss of reflective snow energizes evaporation.
Yeah, and it's got all the citations to the other discussions around that, and so it's an interesting string of papers to read to try to understand kind of what we're thinking as far as these temperature-induced changes on the stream flows.
And they do have a little bit on this about the future, but we won't get into that. I think the take-home point here is that the warming does matter, and it relates to snow, and that snow then drives that ET feedback. And it also brings up a lot of kind of juicy questions. It's like, okay, so can the system withstand? We feel pretty confident. The climate science community feels pretty confident that a 1 or 2 degree warming signal will transpire. And does the system have the ability to accommodate a 15% reduction in streamflow from that?
They're really good questions. And this is actually where it goes back to the Bureau Rec and those 24-month studies and the longer studies is there are so many moving parts. And, does that time average 10% per degree C, what does that actually translate into hydroclimate variability? Does that scale to a 50% reduction in a string of years, or something worse, or something that's, kind of novel in the actual hydroclimate time series, but on the time averages out to being 10%? Those are the things I think are really interesting, and I don't have a good handle on that.
Okay, so I think we've been at this for a while, but we did want to cover one other thing, which is just looking forward to seasonal forecasts. Anything that you want to say about that? I mean, it's been calling for dry conditions for a long time now. For each month, it seems like we've looked forward, and there's been a drier signal. It hasn't actually played out in that way. It continues the seasonal forecast for the next 3 months. It's a dry time for us anyway here in the Southwest.
Yeah.
Calling for below average rainfall. I'm not sure how much what that means. The 8 to 14 day forecast is pretty bullish on some weather coming in. Obviously, in the next, we can see out for the next 4 or 5 days, and there is a low moving past, but longer than that. The
rest of March, looking at all the guidance from the 6 to 10 and some of the weather timescale models all the way out through the 8 to 14, anyways, rounding out, and the 1 month outlook from the Climate Prediction Center for March actually does have the Southwest. The 1 month precipitation outlook has all of Arizona and parts of New Mexico lean towards above average conditions. And that's just this persistent pattern of these storms kind of training through the area. And so it looks like there's a decent chance that we end up above average across much of the Southwest, maybe even the northern part of the state getting in a little bit of action. There's still a little outside of that. It's not quite as strong a signal in the northern part of the state. So it does seem to center on southern Arizona again. And then you shift over to the March, April, May outlook, and it is actually for below average precipitation lean in that direction for all of Arizona and New Mexico. But again, they've been 2 different forecast signals. And the seasonal outlook, the 3 month outlook, has really struggled the whole winter and is lean dry. It has got it right over the northern parts of the region, but is centered on southern Arizona and has been completely in the opposite direction.
I guess it's not so surprising it struggled, given that
it had nothing to latch on to.
Yeah, it had nothing to latch on to.
It really, I mean, in the forecast discussions, we're pretty honest about that the confidence was low. It's interesting that they did paint the Southwest, even though there wasn't really nothing to go on. And as the shorter term outlooks continually pointed in the opposite direction. So that's a tough job.
This time last year, people were talking about the poppy apocalypse. That's probably not going to happen.
Are you sure?
You don't think you think it will happen?
I do. I mean, I drove
not in California. That's where.
Oh yeah, California, no. But our low desert. I drove out to Yuma 2 weeks ago, and it's Good.
Oh, is it?
It's amazing. Yeah.
This is a great time. I love this time of year.
Yep. And our yard is
you
totally.
You remember what it was like in California last year?
Crazy. Yeah. Anza Borrego. I saw the pictures of that, and even the low desert here looked just about the same. It's really pretty good in southwest Arizona right now, and the low deserts. And Picacho Peak looks like the hills of Ireland right now. So that'll be a place to celebrate St. Patrick's Day next week.
All right, Mike. Well, hopefully we can do this podcast live. In person next month. If not, we'll zoom in.
All right, let's zoom in. Social distancing.
It's good to social distance from you.
My breath is pretty good.
All right, everybody. I said this last time, and I'll say it again. If you have a chance to like us or promote us somehow on, how do you do it?
Smash that like button.
Rating or review on the iTunes store. Yeah, please do. That would be great. We're trying to spread the word a little bit, given that we are the longest lasting podcast on Southwest climate. Our claim to fame.
Our only claim to fame.
All right. Have a great month.
I don't know. Check that. I'm into hydroclimate, man.
Temperature not an issue.
No, I think we should talk about temperature. I just didn't do it.
I fumbled that transition.